All right, I'm seeing some words. I'm going to read it twice, once for context, the second time for annotations. A piece of ribbon measures 2 6/10 meters. Express this length in centimeters. All right, let's see what this problem is about. I know I have a piece of ribbon. I can envision this in my brain. It's kind of long. It's measured in meters. Remember that 1 meter is about the length from your shoulder to your fingertips. So that's like pretty long. They want us to express this length in centimeters. I'm just trying to get a picture in my head, and I know that centimeters, they're kind of tiny. They're like maybe half the width of the top, or excuse me, half the, oh, that's a good one actually. Like the width of your pinky. Centimeters are super small. So I know that meters are really big, centimeters are really small. Let's read this a second time so we can start annotating. A piece of ribbon measures 2 6/10 meters. Okay, so this is what I'm starting with. Express the length in centimeters. So they don't want us to keep meters. They want us to convert into centimeters. Okay, let's come up with that plan. Make sure that you have a notebook and pencil in front of you. If you do not have those materials, you're going to go ahead and pause this video so that you can get those now. All right, started on our plan. So the first thing we need to do is convert my 2 6/10 meters. I'm going to put an M because that also stands for meters. And I'm going to convert that into centimeters. I can express centimeters as cm. Now, I don't know the rule for meters and centimeters off the top of my head, so I'm going to go ahead and look at my reference sheet that's at the corner of my page. Do I see meters or centimeters anywhere? Ooh, I actually don't. I'm wondering why. Oh yeah, because this is a metric conversion problem. My reference sheet only shows customary conversions. So remember, your reference sheet shows those customary conversions. Those are things we use only in the US. Metric conversion, remember, because we're kind of weird, I'm not sure why. Metric conversions is used everywhere else. For a metric conversion problem, we've learned about the metric ladder. How many steps are in the metric ladder again? That's right, it's 7. Go ahead and make your metric staircase. 1, 2, 3, 4, 5, 6, 7. We also learned about something kind of silly to remember what each step stood for. Something about some chocolate milk, something about some king. Take a moment to remember from class. King Henry does usually drink chocolate milk. And let's take a moment. Usually we would keep it like this, but let's take a moment because it's been a while to see what each of these steps or these letters stand for. King stands for kilo. H stands for hecto. This first E stands for deca. U stands for your basic unit. What are some possible basic units? Let's see. If we are measuring liquid, we know that we can measure in liters. If we're measuring mass or how heavy something is, we can measure in grams. And lastly, if we're measuring the length of something, we can measure that in meters. Okay, going back to the rest of our ladder, the second D stands for deci. This C stands for centi. And the M stands for milli. Going back to this problem, I was interested in meters and centimeters. So I'm going to go ahead and either circle or put a star. My meters were at my basic unit, and my centimeters were right over here. I'm starting at meters and I'm going down to centimeters. How many powers of 10 are these away from each other? Think, how many steps did you have to take to get from meters to centi? That's right, 2. So I know my rule is going to be 10 to the power of 2. We've got a lot of information on our paper right now. Let's actually put everything together so that it makes sense. So, again, I know I'm starting with 2 6/10 meters. I'm trying to figure out how many centimeters that is. I need to figure out, am I going big to small or small to big? Let's take a look at our metric staircase. If I'm starting at these meters and I'm going all the way down to centi, I'm going from big to small. If you were going the opposite direction, then you would be going from small to big. Let's think. Go back to that song. What operation do we have to do? Big to small, we multiply. Small to big, we divide. Since this is a big to small problem, we are going to be multiplying. And because of our handy dandy metric staircase, we know that our rule is 10 to the power of 2. Putting it all together, 2 6/10 meters times 10 to the power of 2 will give us our final answer. You can do this in your head possibly. I always like to make sure my answer is right, so I'm actually going to draw a place value chart just to make sure. Okay, I've got my 2 6/10 meters. I'm also thinking in my brain, if I'm multiplying, are my digits moving to the left or moving to the right? I know when I'm multiplying by a power of 10, I'm moving to the left, and that's why I have so many extra spaces to the left instead of to the right. Okay, have my 2 6/10 meters. I'm going to be moving 2 place values to the left because I'm multiplying by 10 to the power of 2. Oops, how'd that square get there? I don't know. 1, 2, times 10, times 10. All right, my 2 moved over, my 6 moved over, my decimal stays in the same exact place, and I can go ahead and put a placeholder 0 right there. I now know that 2 6/10 meters is equivalent to having 260 meters. My answer is 260 centimeters, and you could go ahead and box that in.